I'm Anil Kumar. Welcome to my series of Grade 9 Review Direct Partial Variation. So in this video we will understand what is direct variation, what is partial variation, and we'll take up some applications based on direct and partial variations, right? So these are two different things, direct or partial variations. So whenever you see a graph which is kind of a straight line going through the center or the origin of a coordinate plane like this, a straight line going through the origin, it represents direct variation, correct? So that is how it is represented. What basically it means that one variable varies directly in relation to the other. So these two variables, we consider one of them as independent variable. Independent variable is always along the x-axis. So that is the independent variable, right? Normally we'll say x. And here we have the dependent variable. Let me write dependent like that. So we'll write y for dependent variable. Direct variation, since it goes through 0. Example could be, let us say you are driving at a constant speed of, let us say, 60 kilometers per hour. In that case, if you start from home, then the distance from home is 0. But as the time passes by, and if you're driving at a constant speed, then every hour you are going away 60 kilometers from your house. While in such application questions, what we do is, sometimes we use different variables. So it is not necessary that you use the same variables all the time, correct? You could use different variables. So in that case, we will use distance d, and we can write units, kilometers. This should be time t, which is distance is variable, and it depends on time. Time has no control. So we'll put time in hours, and on this side we'll put distance in kilometers. So distance is directly proportional to time if you are driving at a constant speed of 60 kilometers an hour, right? In that case, if you drive, let's say from your home away, then the graph could be like this, where every hour you cover a distance of 60 kilometers, right? So let us say that is the distance being covered. So likewise, you can get few points on the graph and say 1 hour, 2 hours, and then 3 hours, and here the distance will be 60, 120, 180, and so on. So that is a direct variation example. So in these cases, what you observe is that this dependent variable is related with independent variable with a constant multiple. That is to say, we can always write this as y equals to k times x, where y is the dependent variable and x is the independent variable, and k is the constant of variation. So if x is 0, y will be 0. In our example of speed and time, the constant speed of 60 represents k value. So that is how the applications are related. So this is all about direct variation, right? Now there could be cases where we may have a partial variation. Now let's talk about partial variation. What is partial variation? In this particular case, we could have an example of partial variation also. Let me show you graph for partial variation separately. So we'll take two examples, and then we will see how direct and partial variations can easily be identified, right? So in partial variations, what really happens is, let me take this example and extend it. So let us say that we start from our friend's house and then drive at a speed of 40 kilometers per hour. In that case, we are starting from away from the house. So if this distance, let us say, is 20 kilometers, in that case, at time t equals to 0, our distance was 20 kilometers from the house, right? Now if you go away at the speed of, let us say, 40 kilometers per hour. In that case, the equation which represents the distance, so this becomes distance, which is dependent on time, can be written as distance is equals to 40, the constant speed, times time, plus the original distance, how much away were you initially when time was 0. In this case it is 20, so we'll write 20 here. So that represents partial variation. What you will represent here is that when t is 0, at t is 0, your distance is 20, not 0. Do you see the difference between the two? So in partial variation, at t equals to 0, you are not at 0. If you are at some other point and your graph can be represented by a straight line, then it is a partial variation, right? Now to give you some more examples of partial variation, we could take example of, let us say, a banquet hall you want to book for a party. And you say, well, the banquet hall person says that they are going to charge you at least $100 for booking, right? And then based on number of persons, they will charge you extra, right? So they say, well, for every 10 persons, we will charge $100 more, for example, right? So for every 10 persons, let us say, since I've drawn like this, let us say for every 10 persons, they charge $50 more. Every 10 persons, they charge $50 more. In that case, it is a partial variation. Partial variation because when no one attends the party, even then, for booking, you pay $100. And here, what are dependent and independent variables? Now, the dependent variable, of course, is the amount charged in dollars. And independent variable is number of persons attending the party. If the number of persons is 0, you still pay $100. And therefore, I could write this as amount is equals to, you could write the $100 first, plus the rate. Rate is 50 for 10 persons. Do you understand? 50 for 10 persons. Or for each person, it is, you could write 50 over 10, n, or you could write 5n. Do you see? $5 per person, for example, right? So likewise, you can have a partial variation examples. Now in these graphs, you will notice that they always, when it is partial variation, they don't start from origin. But the important thing here is that the graph is represented by a straight line, and therefore it is direct or a partial variation. If it starts from the origin, it is direct variation. If it starts not from origin, or if it does not cross the origin, in that case it is not a direct variation but a partial variation. Now here is a question for you. Here's a graph for you. You have to tell me whether this graph represents direct variation, partial variation, or neither. Now here it starts from 0 and it's going like this. Now is it direct, partial, or neither? It starts from 0, it could be direct, but it is not direct. Can you tell me why? Because it is not linear. Do you understand? Since it is not linear, it is not direct. It has to be a straight line so that I could write it as y equals to a constant times x. You get the point? So if this is x and y, this graph is not a direct variation since it is kind of curved. So this is a very important question to understand. So every graph which goes through the origin is not representative of a direct variation, correct? So that is how you can figure out. Now let me give you a few equations and then see, your question now is to tell me whether these equations represent direct variation or not. Let's say we have 200 plus 75x. Does it represent direct variation or not? Or partial variation or not? So we could have y equals to 25x, or we could have y equals to x squared. Now these are three different equations. Can you tell me which one of these represents direct variation, which one represents partial variation, and which one represents neither of these two? And provide an explanation for your answer. Let that be a question for you. But I hope with this video you have a clear picture of what is direct variation, what is partial variation, and how to do questions related to direct and partial variations. Now I'll give you links which will help you to do some practice questions. I hope that will help you to review this chapter on direct and partial variations. Thank you and all the best.